Okay. I can see I have 7 of you on the stream already. Hi, guys. Good evening. Go ahead and drop a message in the chat if you can hear me. Drop a message for the others on Discord. Right. We are going to be discussing object oriented JavaScript uh, tonight. Okay. All right. So drop a message for the others before we start. Okay. All right. So drop a message for the others so that we can all, at least we can have enough people on the call um, within the next 2 minutes. All right, so let's stop the music. Let's get started. So I can see some messages already. Okay, so Binta, I think Binta got here first. Binta, kudos to you. Good evening. All right. Chooks, good evening. Abraham, how are you? Christian Phoebe, Favor. I think I skipped a name there because I don't know. Is that okay? I was thinking it was a bot. That's AN. All right. Okay, thank you. Thank you very much. I can see someone viewing from LinkedIn. Shedozie. All right. Okay, so let's get started. I'm going to share my screen. We're going to be covering object-oriented programming first from a conceptual, angle before we dive into, looking at it from JavaScript, right? As well as, writing some sample code. Okay, so please pay attention. And if you have any questions, do well to ask your questions on the fly. Drop your questions in the chat. I'll be looking at the chat. Okay, and of course, I want to see your questions in the chat. All right. So let's go ahead and share my screen already. Okay. Let's see. Sharing my screen. All right. Okay. So yeah, you can confirm in the chat if you can see my screen. Let's try to zoom this in so that I think this is much better. Good. All right, guys. So I'm going to be taking this from a conceptual angle first, right? Before we dive into writing some code. Right now, I have Excalibur opened up. This is where we are going to do some diagramming. I think most of you prefer if this is in dark mode. So let's switch things up. Okay. All right. Okay, great. So when we say object-oriented programming, now we are diving into this already. So when we say object-oriented programming, let's take this off. Zoom in on this object-oriented programming. By the way, I know we have been learning JavaScript for a while now, so most of you are already familiar with the basic JavaScript constructs, right? So we can actually perform arithmetic operations. We can probably do some fundamental operations, using JavaScript on the the DOM, the document object model, right? So yeah, we can do some of these things already. Um, for now, we are simply going to see how we can, um, represent objects, right? Represent objects, including their properties, their behaviors. We're going to model some of these things using code. Let's look at this object-oriented programming from a more realistic sense. Okay, so let's assume you have a particular object. I'm going to use maybe an employee, right? or even a human. Okay, maybe that is more realistic here. Before we talk about, before we try to explain some of these things or talk about, the meaning of objects, or the meaning of some important terms like inheritance and the others, let's try to understand what we mean by object in this context. When we say object, we're referring to anything that we can represent, as an entity, and that particular item should have properties as well as behavior, right? Behavior is what we would then refer to as methods. Okay, so properties of a human, for example, we can mention things like you know the hand, right? The hand. We can mention the legs. These are properties, okay? And every property should have a value, right? Okay, that's wrong. This is what I should use. Okay, so we have legs, right? We probably have let's say we have okay, I think that's fine. Yeah, hands and legs. Okay, so we have hands and legs, to be the properties that we're using here, right? Of course, we can actually have other items. I wanted to mention gender, but let's just work with this for now, okay? So hands and legs. And if these are properties, it means they have values, as I mentioned. So of course, hands, we should be looking at two, except you have more than two, but let's just stick to two for now, being the default, right? So these are the properties of these, these are the values of these properties. So legs, two, all right? And I'm just trying to give some of these examples. Now we're looking at an example of a human, okay? If you have something else here, let's say we have a car, for example, a car. Your car can have maybe the model, right? Maybe the color, okay? Um, yeah, I think maybe I forgot to add. Let's just add something extra here so we can have three items on each. So let's add age, right? That's what I was actually thinking about, okay? So we have age, and yeah, of course, the age also has a value. The age is a property. What's the value? Let's just work with 40 here. Okay. So these are the properties, right? And these are the values of those properties. Now I want you to actually look at this from that that point of view. We have properties, we have values. Now we'll get to the behavior or the methods, but we'll get to that shortly. Let's just work on this second example. We have the model of the car, we have the color, and we'll probably have I don't know, maybe the price. Okay, so these are some properties of the car as well, and we can as well look at the values. So just to put in some random values in there. Now, these values can be, dynamic, which means you can actually create this object and allow the users to create a new version or a new copy of this object, right? A new copy from this object. I'll show you what I mean by that. Then we'll dive into talking about the details of OP. All right. So the price here, let's just assume I say maybe 2 million naira, right? Just an assumption. The color, let's say red. Okay. So if you notice what I'm doing here is just mapping properties and values, because I'm trying to pick this up from a standpoint that will make it very easy for you to actually think about. Okay, make it easy for you to reason about. Um, Not reading a lot of books and getting confused at some point, right? So for the model, I'm just going to say Toyota. All right, so this is what we have. Let's put in some of these arrows here. So that is 5. Okay. All right. So now we have one object. We call this object a human object. We have the car, and for the car we have a model, color, price. We're able to put in these properties, and then we also have these values. Now this is an example. When you are working with objects, you should be able to. What you're creating is basically what we refer to as the most people call this the base objects, right? Most people can call these the base objects, or you can also hear people call this a blueprint, right, of your object. So let's say base object or your object blueprint. Blueprint saying meaning that it's kind of showing you what this object would look like or should look like, right, as a base. So whatever we create from these objects, right, you're going to be able to create new copies from this object. So now this is a car. We can create a new car and call this, Marv's car, right? Or let's say John's car, right? And when we create John's car, we can then pass in, the values of each of these properties, which is the model, the color, and the price. Okay, so from car, so we can just call this John's car equals new car. Now we're going to get to this, right? Equals new car. Okay, so the point is we have created the car, which is the object, the base object, and now we are able to create new versions of that car while passing in the values. The colors can be different, the price will be different, the model of the car will be different, right? The same way we can also choose to create a new human by saying let John equals new human, and we can pass in the legs, the numbers of legs, the numbers of hands, and of course the age, right? Okay, so I hope you are able to get like a little bit of a context from here. Let us go back into object-oriented programming description, and I'm going to give us a very simple description here. Okay, so object-oriented programming is basically a programming style or paradigm that organizes software design around the concept of objects, okay, which are the entities that I have mentioned here. All right. So we also refer to them as, the instances of classes. Okay. So let me go ahead and paste this here. So that will be easier. Let's go ahead and duplicate this, paste that in here, and let's break it up a bit. So, all right. Okay, so this is what I have. Object-oriented programming is a programming paradigm that organizes software design around the concept of objects, which are instances of classes. Okay, and we have some, fundamental principles of working with OOP, right? Which is object. When I say OOP, I mean object-oriented programming, of course. Okay, okay. I think I have that here already. Yeah. Okay, so we have some of these fundamental principles. Now, uh, depending on how deep you've gone into OOP, you would get to see even more details when it comes to those principles, right? But I'm going to mention the I would say pretty much the standard principles here. So we have principles like inheritance. Okay, we have principles like encapsulation. And of course, just forget about the big grammar here, right? I would explain each of them as we progress. So we have polymorphism. Okay, so we have polymorphism. Now these are the three main principles I want us to look at, right? Yeah, we basically have others, but let's focus on these three. Okay. So first off, before we even dive into the details of these three, I just want us to understand that from these examples I gave you, I gave an example of an object. I refer to this as an entity as well. I also mentioned that, so I mentioned objects. So I mentioned that these objects have what? Properties. Now these properties are what you can also refer to as parameters, right? Or arguments. Let's just call that args. Okay. So we have the objects, the properties, or you can call them params or args. Okay, and then the properties, of course, would have values. Okay, so let's just indicate this. All right, so you have the objects have properties, and the properties have values. Now, the object also have what we call the methods, right, which are also known as the behaviors. Okay, let's just put another arrow here to describe this. Now, what exactly are the behaviors? Given this example I gave here, I said human has age, hands, and legs, which are the properties, and these are the values of those properties. We can add one behavior here to say humans can walk, for example. Okay, this is the behavior, right? Humans exhibit this kind of behavior. They can walk based on what we have defined here. They can also maybe eat. All right, so these are behaviors, and then we can refer to these behaviors as methods. Okay, we can refer to these behaviors as methods. We can also say humans can walk, which is WRK here. Okay, so that is also a behavior. Now, there are so many behaviors you can attribute to a human. Now, it depends on what you are trying to build, right? When it comes to car, you can say drive. You can actually put in a bunch of things here depending on the behaviors you are trying to model, right? Now, I want you to think about this, for a minute, okay? So, if you say you are trying to create, let's say you are building an application. Your application is targeting, I don't know, maybe your application is meant to target a supermarket. All right, I'll come back to this. Your application is meant to target a supermarket. So let's just, do a quick, description here. So you're building an app. Let's call our developer Rose. Okay. So Rose is building building an app for a supermarket. All right. Now, Rose is going to build that app, and Rose would have a way to describe the products in the supermarket. Now, there are so many things you can actually think of as objects within your system. The product is one of them, right? But remember that even the user is one of them, right? The customer is also going to be one of them, the customer. Now, there are so many things you can mention, so many entities. Think about it. What are the entities? And each of these entities, of course, would have the properties, the values, and the behavior. Okay, but let's just focus on one for now, which are the products. The products you are going to add to your app, they would all have properties, right? So let's put it this way. We have the product, and I'm going to give an example of a product, right? So an example of a product here can be maybe I don't know, supermarket. Let's say let's say a drink. Okay. So that is a product. We have a lot of products, and each of these products, for example, would have parameters. Now, what are some parameters you can think about for this product? Let's just say a price, right? The price is, of course, a parameter or a property. The price is a property. What else can be a property here? Maybe the type of product. Of course, products would have different type or categories. Okay, so and then each of these values, each of these properties would have values, right? So you can have maybe 1,000 naira, for example, for the price. For the type, I don't know, let's just say, do we have any other apart from, okay, yeah, let's just say soft drink. Category, um I don't know, should I say alcoholic. Okay, now that's quite weird, right? For my example, but don't mind me. I don't really know much about. Yeah, let's just keep it this way. We have the product, a drink, for example. A drink has the price, the type, and the category, right? And then you have the price, which is 1,000 naira. The type, let's say soft drink. Oh, this is quite weird. Soft and alcoholic. Okay, now that's funny. Um, I don't know. Let's just assume I did not include type. All right. So we have price and we have the values of those the values of those properties. Now this is a very good way to describe how you as a programmer, how you as a developer would leverage thinking about these items as objects, right? Entities with properties. Those properties have values. Okay. You can also choose to add those behaviors, right, or methods to your products. Maybe you have a product a method that can be something like um, delete, right? So where you have product.delete, right? That can be an example, but we'll look at more reasonable examples when we start writing code. Okay, so I just took that off. I hope that makes sense to you now. You have entities, you have the properties, you have the values, and you have the methods. All right. Okay, so coming back to this diagram, an object has the properties, and of course, the properties have values. Then you have the methods or the behavior, all right, within that object. Okay, so I hope that makes sense. I have used multiple examples to break this down. We're going to now discuss, the concept of inheritance, encapsulation, and polymorphism. Okay, let me look at the chart if you have any questions. All right. So I wish my lecturer 6 years ago had explained just like, oh, thank you. Um, all right. So I think that's the only message there. Do we have any other message? Okay, nice. All right. So let's proceed. Let's look at inheritance. That's the first one we have there. Okay, so come to think about it this way. You have created that blueprint, which is like, the human blueprint that I used here. You have created a human blueprint, and you want to create another blueprint that can take some properties from this because they are kind of related, right? So we have human, for example, and we're about to look at two categories of human. Now, this is just an example. Let us say we have parents, which of course is a human, and then you also have a child, right? Okay, so this is what I want us to look at. We have created the human class or the human object, and then we say, okay, we want to create parent out of human, right? In the human object, we have set some of these properties like age, hand, and leg, all right? Um, and yeah, we have set these base properties here, age, hands, and legs, and we also set walk, and eat, okay? Let's pick two from there. Let's just take two, okay? So inside human, we say age. I think what I can do is to use a regular text instead of an object. Like, yeah, so human. Remember, we have those set of items. So I'm going to just say brackets, age, hands, and legs. Now these are what? These are the properties. All right. So for the methods, we have walk. We have walk. Okay. Or maybe we can say eat. I mean, well, humans would love to eat. I for sure love to eat. Okay. So we have this. Now for the parents. So I'm going to create parents. Now, parent is going to inherit from human, right? So we're inheriting, let's say, inherit, inherits from human. Okay, so now parents inherit from human. What exactly did the parent just inherit from human? Everything that the human has here, okay? Including the age, the hand, the legs, the walk, and the eat. Okay, so now we assume that wherever we see, for example, we see John, and we say let John equals equals new parents. That is equals, okay, new parents. And then we put it, we can go ahead and put in all these details, the age, the hand, the leg, and we are sure that John should also be able to walk and eat because John inherits all the properties from human. So whatever the human is able to exhibit, John can do that because John is a parent, and parent is parent inherits from human. All right. So John should be able to include the age, the hand, the legs, and John can also walk and eat because John automatically is a human. John inherited the human traits and the human behavior, so John has all these options. Okay. So that is it for inheriting from human, right? When it comes to the parent object that we have created. Now, if John, which is okay, if the parent human, if the parent object here, sorry, if the parent object here decides to now say, as a parent, I can also pay taxes, right? Now, this is a new behavior, right? This was not included in human. This is a new behavior. So although the parents inherit everything from here, they also have an additional property that only a parent should be able to exhibit. So John should be able to pay tax. Okay? John should be able to pay tax because John is a parent. Now, let us assume that we now have child. Okay? And child also inherits from human, right? Which means child would inherit age, hands, and legs. The child would also be able to walk and eat, but then the child should not pay taxes, right? Now, this is an assumption. I don't know. I am just trying to make this clear, very clear to you. We have the human. The human has these properties and this behavior. The parent inherits from human, which means he can do all this, and the parent also has an additional method, which is pay taxes. Okay. Now, John, who is a new parent, can actually have all these properties because the parent inherits from human. So John has all this, and John also has the ability to work and eat. Because we have introduced pay taxes here, it means John can also pay taxes. When it comes to the child inherits human as well, which means the child has the ability, right? Let's create a new child here. So I'm going to create a new child. I would say let's John Jr., right? So John Jr. is a new child. Of course, it has age, hands, legs, and of course, John Jr. can walk, eat. Now, John Jr. does not inherit pay taxes. Remember, it only inherits human, so it does not have the ability to pay taxes. Now we want to include a particular action that a child should be able to perform. So, give me an example. Someone in the chat, please give me an example. Give me an example in the chat. Okay, anybody? So, what can John Jr. do? What can a child do? Yeah, that a parent is not. That the parents should not do. Give me an example. I have 39 of you. Just give me an example. Any example that makes sense. I don't know. The examples I have in my head right now, probably someone will say, "Oh yeah, crawl." Okay, actually, parents can crawl, but let's just work with that example. That makes sense. Okay, so since we don't have crawl in here for the parents, which is good, we can now say crawl, right? So the child should be able to crawl. Play. I think play makes play. Parents can play, but yeah, play makes perfect sense here. Okay, so let's work with play. The child should be able to play in our example, parents shouldn't play. They should always be serious, paying taxes. So here the child should be able to play, which means John Jr. automatically should be able to play, right? Okay. We're not destroying things. Okay. Favor, please calm down. All right. So John Jr. is a child with these properties. John Jr. can walk, eat, and John Jr. should be able to play. All right. So now you see, this is basically inheritance in action. We are going to try some examples. We're going to do something, even more practical. But I hope you get, the concept. Okay. That is the main thing. I'm going to move this aside. All right. So that is for inheritance. All right. So now let's talk about encapsulation. Okay. By the way, if you have any questions, let me give you a minute. Go ahead and drop your questions so that we can move on to the next, which is encapsulation. Encapsulation. All right, so drop your questions in the chat. I'm actually waiting to see your questions. If you don't have any, then of course we can move on. If you have questions, please drop your questions in the chat so we can dive into breaking it down for you to understand. You just have 1 minute. Please drop your questions in the chat. Okay. All right. So I don't think we have any questions. Um, all right then. Let's go ahead and discuss encapsulation. Okay. All right. So let's talk about encapsulation here. I'll give this example. You basically have an object, right? You have an object that should be able to that object should have a behavior, and that particular behavior should be able to perform something outside the it should be able to perform something that the caller do not really know the details to, right? Because it's wrapped inside that particular, maybe a method or a behavior, right? I'm going to show an example that will basically, make it more detailed, right? To make it more easy for you to understand. All right. So the point of working with encapsulation simply means um, bundling your data, right, or bundling your method, which is the behavior, into a single unit in such a way that you can call that particular behavior and it will perform that action. That action, the combination of actions would be right within a method. All right. By the way, before I even proceed, just to make this clear, right? A function. Some people get this mixed up. You have a function and you have a method, and they are like, what exactly is the difference between a function and a method? They look the same. Now, if you are writing your code, for example, and you simply have a function, maybe hello world, you have a function that looks like this. You are returning some item, maybe you have data just here. Now, this is a function, correct? A method is basically a function that is found within a class, right? Or within the blueprint of your object, okay? So if you have a class, and we'll get to work with, classes shortly. So a class like human, which is what we have been looking at. And then you have something like, we said a human can walk, right? So a human can walk. Now, this is what you refer to as a method because you can only call walk when you have defined a human, right? It is a behavior, right, that is attributed to the human. That is what makes it a method. Now, I'm giving you this explanation because if you are probably studying computer science or maybe you're in school and they say a function this particular one returns a value, this does not return a value. But I mean, come on. A lot of people found that very confusing back then in school, right? And even till this day, please just look at this from a very practical standpoint, right? The function is going to return something, which makes sense, right? We're returning data. The method would also return something. I think the definition that we get, in some of these environments usually get to confuse us, right? This is a function, no doubt, but unfortunately, this function is wrapped within. And by the way, when I say unfortunately, it makes it look like a bad thing. It's not a bad thing. This function is just wrapped within a class or within an object. So it makes sense to now say human.walk or the instance of the human, which can be John, right? Dot walk. Now that dot walk happens to be a behavior that is tied to John, right? Because John was an instance of human, which makes it a method. Okay, and a function is just sitting on its own, performing that action is a unit of computation, right? So if you think about this, they can basically do the same thing, but the difference here is the way it is used, right? This is used from the context of an object, right, or a class, and this is used from just being a single unit of computation. That it can perform that action. Now let's go back to encapsulation. Encapsulation here basically describes, in short, we call that data hiding. Okay, so data hiding, you hear people say binding, blah, blah, blah. Okay, what you are basically doing is that you have some behavior, you have some actions that you want to capture, right? But then you want to wrap that into a different, you want to wrap it into a method, okay? So that, when you call that particular method, it will be able to perform, that particular, it would be able to perform that particular action. Now, most times the properties you use within this method are, set to be private, right? So that someone would not be able to just call, the human and say human.leg or human.this. You don't want people to be able to change things randomly. So sometimes you want to set that, you want to hide it, right? You want to hide it. Now, I would give an example. You basically have a class called human, right? And you don't want to give them the flexibility to be adding hands and legs because by default, you want the hands to be set to 2, right? You can ask them to put in the age. When they put in the age, you, the programmer or the software engineer, you are going to create a new human, accept the age, but then go ahead to include the defaults that should be there, right? And I'm just giving this as an example, by the way, right? You should not force people to accept your values. It depends on the business, the business or whatever it is you're building. There are some rules that are set to be defaults. There are some things that are meant to be defaults, right? When you are building something, there are some things that you probably want to set as defaults, and you don't want people to alter it when they try to use your code, right? So what you can do is that if you have a new version of human being created, let's say we have John equals, this is John equals new human, right? You allow John to pass in the age, okay? But then when you are working with, John, when you're working with this property, you should be able to allow John to say, John dot maybe get legs, and you want to get your response as 2. John did not set this to be 2 on initialization, right? But you have set this within the code. Maybe within your constructor, we call that a constructor, and I'll get to show you an example, right? Or maybe you want to set that within, you want to probably set that. yeah, you want to probably set that within the constructor or some other part of your class, and then you want to have a way to get that value because you have hidden it inside your class. You did not set it, but you should be able to get it. So now when I say get legs, I'm getting the value of 2, although I did not set 2. I have hidden that particular property, and I did not make it flexible enough for you to simply come and change it. Do you understand? So we are able to hide this data, and we're able to use that particular data for some actions depending on what we're trying to achieve. Now this is an example, and we will also look at another example shortly, right? But this is basically referring to data hiding. Let's just keep it at data hiding. We are hiding data because we want to use those data for some sort of specific logic, right, tied to our business, tied to our rationale, tied to the reason behind the code. Okay, so data hiding, that is encapsulation. All right, so let me quickly look at the chat again if I have any questions in the chat. Okay, so someone said, what exactly is OOP and how is it better off than functional programming? Someone said OOP is more error proof. Yeah, I mean that is from Eva. Actually, I won't put it that way, right? That is not very correct. Okay, so when you say error proof, it is not error proof. It depends on the developer at the end of the day, right? It's just a way to think about things. Okay, some people are very good at thinking about things from an object standpoint. Okay, they can think about I mean, just think about anything right now. Okay, think about the road, think about the fan, the AC, the refrigerator. Think about these things as objects, and then you realize that you can easily attribute these objects. You can put in attributes, you can put in behavior, right? So it makes sense for developers to love, right, OOP, and love the patterns behind OOP, right? OOP can be easy, it can be difficult. Functional programming can be easy, it can be difficult. I personally love functional programming. I use it almost all the time, right? It's my go-to pattern. But OOP is also very good to think about, your approach into development, and you think about objects. Okay, so yeah, you think about the objects, and that is for Bernard, right? So if you love to think about things, as objects, then yes, that is a good one. Is a good way to go. So let's look at, please, how can the child object inherit the human object and also add new actions to it? I think I explained that already. Okay, if you did not understand me, please let me know in the chat. Let's move on. Let's talk about polymorphism. All right. So polymorphism is simply a way to have an object, exist, or you have a behavior exist in different ways. Okay. So polymorphism. All right. So that's the third thing we're looking at here. Okay, just to create some space. I don't know. This guy looks too big. Let's reduce this a bit. Okay. All right. Okay, so basically polymorphism, it's you are giving that object, right? You're giving that object the ability to be treated as what's the best way to explain this? I want to explain it in a very simple way. Okay, let's put it this way. You are able to create a single interface, right? But then you are able to also allow that interface to be used in different ways. Okay, so you are able to enable that single interface to be used or represented in different ways in different types of objects, right? Yeah, and I will show an example. Let's look at an example here. All right, so let's say we have a function. Let's say we have a class, and then within that class we now include a particular method, right? And that method, we can use that method to compute for some sort of calculation, right? It can be calculating like the area of the area of a circle. Yeah, that makes sense. So we can use that to compute for the area of a circle. We can then extend that particular object and change or override, right? We can override that particular method and change that particular method to compute for the area of a triangle. Let me show you an example. So I said it basically is basically allowing a particular object, to exist in different shapes or different forms. All right, so we are going to create a simple class here. Let's call this class a shape class. Okay, so if you have a shape class, a shape can be a rectangle, it can be a circle, right? It can be a trapezium or a parallelogram, okay. So let's just work with rectangle and circle here, right, as an example. Okay, so if we create a shape class, and within the shape class, we're able to define, like the details of that class. Okay, we're able to define, the name of the shape. We're able to define, I don't know, maybe the type of the shape, right? Whatever it is. We can then have an assumption here that we're calculating. Let's call that compute area. Okay, I'm sure most of you did basic maths. Okay, so if you did basic maths, you understand that when you're computing area, you have the area of a circle, the area of a rectangle. Quite, of course, I believe you understand this. Okay, so if you're computing the area, for example, now we're going to create. This is our base, right? So let's call this our base objects. Our base objects. Within our base objects, we have the behavior of okay. So compute area, that is the behavior we have. Okay, so what you can then do is that you can create rectangle and of course inherit shape. Correct. So we inherit shape. When we inherit shape, we can also go ahead. Remember, the moment you inherit shape, you have compute area, right? But we can then go ahead and recreate compute area within that within the rectangle object or the rectangle class, and we can now add a new formula, right? Or a new let's say uh, add a new formula. So add new formula for rectangle. Remember, you actually extended this particular one. You inherited from here. This might have maybe a different, let's say, have a base formula. When you get to this point, you also created this again and you change the formula. Now, automatically, what you have done here, we call it a method override. Okay, that is what it is called. It is called a method override. So, uh, we have method override, we have operator overload, and we'll talk about that so later. So we have a method override, which is basically what you've done here. Okay, so when you override that particular method, what is actually happening there is that the new, okay, I think that is override. Yes. So what you're doing here is that the new formula you have added will then be used on rectangle specific instances. So if I create a new instance and I say this is a new rectangle, it is going to use this. If I create a new instance and say this is maybe a circle, all right. So we also inherit shape, and then we add compute area, and now we change this to area of a circle, right? This was area of a rectangle. So a different formula. When we create a new instance, and we create a new instance of a circle, and we say circle.compute area, this method is going to have a different formula that also overrides the previous default that you have here. Now, this is polymorphism. You basically have one method, but this method can be applied in different instances, that of course in different let's call them in different child method, in different child classes. Okay, because this actually inherits from shape, this inherits from shape, right? If you don't change or if you don't create a new version of this, right, that is going to override the default. When you create a copy, so let's assume now we create maybe something like a triangle, right? For example, we create a triangle, we inherit from shape, but we don't create a new version of compute area. If you create a new object now that says L1, for example, let L1 equals new triangle. By the time you say triangle dot compute area, triangle is then going to use the default. Triangle is going to use the default. Now, triangle does not have its own implementation. Circle has its own implementation. So when you say circle.compute area, it is going to use its own implementation. when you say rectangle.compute area, it is going to use its own implementation, right? But if you say triangle.compute area, because triangle does not have its own implementation, it will then go back and use the default from the shape base object. Okay, so I hope this makes sense, right? We have a method, and this method has different behavior in different classes, right? Although there was an inheritance action there, but because we did a method override, it doesn't affect the behavior. We have actually overridden that particular method action, and we've changed the formula in each scenario. Okay, we're also going to apply this in something more practical. So now that we've understood some of these basic concepts based on what I have explained, let's go ahead. We don't have enough time anymore, but let's go ahead and look through the material I have created. Remember that material will be shared via GitHub, so you can always go ahead and download it. Okay, so give me a minute. Let me quit some of these applications that I have opened up. All right, my to-do. Let's take that off real quick. Okay, so what else do I have here? All right, my VS Code instance. Let us click on OOP JavaScript class. All right, so this is the material that I have created, and I'm going to zoom in so you can see this very well. Okay, so let's do that now. Let us zoom in on this. Okay, extend this as well. Zoom in again. Okay, so I hope this is visible enough. Let me look at the chat. If this is not visible enough, please drop a message. Um, how do you create your scripts? Beginning with functions and then try to refactor it. Okay, is that a question? Eva, okay. How do you create your scripts? Beginning with functions and then trying to refactor it and make it object oriented. I mean, it depends. You can just jump into using object oriented. If I'm actually walking through some scenarios, what I do is I actually enjoy using object oriented to mock that specific behavior, right? I can choose to transform the whole thing later to functional patterns, but OOP is good. Functional patterns is also good, right? If you look at right here, I actually have a page open there that says the glossary or a glossary of functional programming, right? So I actually have that as a bookmark tab because there's so many patterns in there that make sense. But at the same time, it is not really about the paradigm. It is about the developer. It is about what you're doing. It's about what you prefer, what you understand, what you are better at. Okay, so it doesn't really matter which option you choose to use. Just use it well. All right. So you can go through this material. This will be shared with you, of course. You can see we have an example representation of a class. This is a person class. Okay. This is how you define a class in JavaScript. All right. And then you pass in, you can add the constructor, which is optional. It's optional because if you don't use a constructor, then you can have static methods. So you can easily call person dot that particular method without having to create a new instance. Okay, but when you use a constructor, it means you are saying this should be constructible, which means we can have a new variable like let mav equals new person. Okay, so when you say let mav equals new person, you can then pass in the name, which is mav, the age, right? And then you can perform some of these actions like printing a greeting message. Okay, you can as well return this and use console.log outside of the class. Let us try that example. I will simply pull up the code that I have created here. So where is that file? So I have the class file right here. We're going to recreate what you're seeing here. Let's click on the class. Okay, so we have class person. Okay, and now we have the constructor. Within the constructor, we have the name and the age. All right, so we can now say this dot name equals name. And in order to be more detailed here, what we are doing is that we are attributing the name option for the person class right here, and we are saying the name within the class equals the name that was passed into the class. Okay, the name within the class equals the name that was passed in, right? When this is called, when this is initialized, when we actually create an instance. Okay, and then we do the same thing here by saying this dot age equals age, right? So the age within the class is equals to the age that was passed in. Within the constructor, you can go ahead and perform some other actions. right? If you want to, if you have maybe some kind of actions that you need to perform in here, yes, you can actually perform those actions in here. But let's just assume that what we need for now is just to be able to say, let John equals new person, right? And now we can say John James, and the age is 45. So if we say console.log John, right, and we decide to print that from the terminal, let's first go into JS, okay, and let's just say node um, class.js, all right, that should be class.js, but of course the same thing. You say we have the person with the name of John James and the age of 45. All right. Okay. So we can also go ahead to say we have a method this time around. So the method is going to be get, or let's just say um, print person details. Okay, now this is quite long, but yeah, I would always recommend when you are actually adding your methods, make it descriptive enough, right? So I have print person details, which is going to be a method. This is a method, right? So this is a method. Okay, it is within the class that makes it a method, right? And within this method, all we want to do is to print out this detail in a more presentable way. So we're going to simply return. Of course, you can do console.log here, but I always prefer to make sure I have methods that do one thing and do it well. Methods that don't really have side effects, or at least have reduced side effects. Okay, and you can always ask me later. Not in today's class. I can dive into talking about side effects in a different class. But for now, we have a method that will print person details. Okay, or person's details. Now we simply want to return, right? We want to return a template string here. So we have a string literal, right? This string literal is going to say, um, okay, this person's name is, right? So let's go ahead and put in the person's name, which is simply this.name, correct? And this person's age is, so let's also bring in this and say this.age, right? So if I should call John dot print person details just like this. So you see I have John dot print person's detail. Okay, now this is quite weird. Maybe I can just say print details. Okay, so print details. If I should run this, this is going to give us the string, which is saying this person's name is John James and this person's age is 45. Okay, so let's take off one of that, curly braces. So now you see we have an object, right, which is person. And now we have that object giving us the method, which is this method. Now let's just quickly describe what we did here. So we actually created a sample here where we say the human has age, hands, and legs. The human can walk, and the human can eat. Okay, let's just replicate this real quick within this file. So let's go ahead and delete everything. We're simply going to have, okay, you know what? Maybe you want to have this. So let's just duplicate, and we'll have class, maybe class 2, right? This can be class 1. That's very poor naming convention, but yeah. Or you know what? Let's just create a new folder. Let's call this a class. Let's put 1 and 2. Let's have it more organized. So I'm simply going to go into class. Okay. So I have those two files in there. Now for the file, this is what we just explained. For the second file, I'm going to delete the whole thing and let's create a new class called human. All right. So when we create a class called human, we have some values, age, hands, and legs. Okay, so now we're going to have the constructor again. We have the age, hands, legs. Okay, and we'll say this dot age equals age. This dot hand equals hand. Okay, this dot legs equals legs. All right. So now within our class, we also have the method that says walk and eat. So we can have walk just like this. Okay, and we can simply say return. Let's just return with the name, right? This time we'll say this dot oh, we don't have a name. wow, our human does not have a name. So let's just say this dot name equals name. Let's start off with the name. Okay, so I'm going to include the name just like this. All right, so name is walking. All right, and we can also have it, and we'll return this is eating. Okay, I hope that makes sense. Let's go ahead and create a new human. So we're simply going to say let Mav equals new human, right? And now we're going to pass in the name Marvelous. So let's just use Mav Magic. Okay, and we have a comma there. For the age can be a number, so let's just put 40. All right, we have hands and legs. Okay, so hands we can put 2, legs we can put 2. So if I simply say print, not print, sorry, that's Python. Python sense coming in now. So console.log, so we can have mav dot walk. Okay, that's the method. So you actually call it as a method. So let's go ahead and say node. All right, class one.js. So I think I am still calling the wrong one. That should be class 2.js. So you see, my magic is working, right? If I have it, okay, let's save that, run that again. My magic is eating. All right. So I hope that makes sense. I hope that makes perfect sense to you. If this is confusing, you can always check this file. What we've done is we've created the human class. We have the constructor, which is where we basically pass in the name, the age, the hands, and the legs, right? And we do this as a way to represent the fact that the name internally here would carry the name that was passed in. Okay, and now we also say this person should be able to walk, this person should be able to eat. Simply return these values telling us the actions, okay, the details of the actions. All right, so that is what we've done here successfully. Okay, so we can, of course, perform the inheritance part here, but I don't want to jump into that, just immediately. Let's take this one step at a time. So if we have, since we have covered, let's minimize this for now. Okay, so since we have covered, the fundamental of, creating a class, you see how you can initialize the instance of that class, and this is how we perform inheritance, right? You use the extends keyword. Okay, so you see we have the person. Let's just copy this. I'm going to simply copy. All right, so that is inheritance. Let's come in. Let's come here and we'll create a new file called inheritance.js. Okay, let's paste this in here. Now, what are we looking at? We have class student extends person. Now we need to, of course, create the person class because that is not found in here. Now let's go back to this and we can simply copy. We already have the person class, but we can simply come back here to grab it from here. Okay, we can just paste it right above this one. Okay, so now we have the person class with the constructor and the parameters of name and age. Okay, so we can also say, okay, yeah, we now have this dot name equals this, and we also have the greeting. Yeah, so now we create a student, which is a person. So say the student extends the person, and we have the constructor, of course, repeating some of those values while also including a third value, which is the grade. Okay, we just included the grade. And what we've done here is we just did an we just overrode the method here with a different response. Okay, which makes this is basically what you're seeing here right now is polymorphism. Okay, we just called greet. We already have greet, but by calling it here, we have just created we have just performed polymorphism. If we now go ahead to create a new student and we say list.greet, let's see what we have by the time we run this. So I'm simply going to say node inheritance. So what you get here is, hello, my name is Alice Smith. I am a student, right? If we take off this option where Alice has its own version of the the greet method, it goes back to the default and it says, hello, my name is Alice Smith, right? So you see, polymorphism allows us to use the same method, right? But then we have different results because we have performed method override. Okay, I hope that makes sense. Someone is saying we should use something realistic. Yes, we are going to definitely cover that. I mean, that is something we have to pay attention to. but a lot of people need to also understand the basic concepts. All right, so please don't rush. Be patient. Okay, so we have seen how to create a class. We have seen how to perform, inheritance. Here we have encapsulation, which is basically what I mentioned the other time, data hiding. So what we are doing here is that we are basically creating a class with some private values, with some private variables. Okay, so by putting the symbol, this hash symbol, or the pound, yeah, the hash symbol basically right in front of the variable, you make it private. You make it private, and it can be changed or adjusted within the methods you have in that class, right? So this is us adjusting, the speed, right? When you accelerate, you increase the speed. When you brake, you basically reduce the speed, right? But when you use get info, you are able to get, the detail of the speed. Okay. Um, so that is what we are doing with this code right here. But you can't just go in there and alter, the speed. You don't want to do that, and that's the point of, performing that, encapsulation, right? I already explained, polymorphism, so I don't need to cover this again. But then we can go ahead, create a new file here. We can call this encapsulation.js. All right, we can paste this in here. So what you're seeing, this is data hiding. Okay. Someone said, you use TypeScript while developing an app. I mean, that's of course up to you. You can use anything that you feel comfortable, working with. Right. Okay, so this is encapsulation. I think I explained this already, but the point is we're making this private, and this will be assessed and adjusted from the methods you have within the class, right? So this is private, and you can make those adjustments. So someone simply has to call .accelerate, and within accelerate, you perform the changes or the adjustment you want to perform to your variables, right? The local variables in here, and at the end of the day, you return the value. So they don't really need to know what happened in here. They don't need to be able to change it automatically as well by themselves. The point is you are doing it this way so that anybody creating a new instance and trying to work with a car, with a car instance, created, should be able to use, accelerate, brake, and of course get info. Okay, so that is the point of, encapsulation. All right. And I said the other time, polymorphism simply means having a method or having an object behave in different ways based on how they are used, right? So it can exist in different ways or in different shapes. Okay. So if I have polymorphism right here, the JS, we can simply bring in that example as well. We have an example right here. So you can actually see this is yeah, this is polymorphism in action. Okay, so take out time to actually look through this. So we have private and public methods. All right, so this is your private variable, and this is of course your private method. Okay, so simply including the hash sign here, makes it obvious that this is a private method, and then you can perform actions on those private methods within your public methods. Okay, so this is the private method right here. It is your public method. Okay, so you see we have private method can be called from a public method. So when you call the public method, it then calls the private method, and it returns the value of the private variable that you have in here, because that has been acted upon by the private method. Okay, I hope that makes sense. We also have static methods. So I mentioned the other time that you can, let's close these guys. We don't need to create like a new example, but when you're working with static methods, you want to be able to create a class, and then throw in multiple methods that you can simply call. You just have a way to organize things into a proper you want to have a way to structure things properly. Let me put it that way. So you have a class here called mathutils. You can have multiple um, methods, for performing different actions. All right, static methods.js. Okay, so here we have a method for adding items. We can have a method for multiply. We can have a method for performing other actions. So you can simply call this without having to create a new instance. You don't need to create a new instance. We don't have a constructor, right? So you just have to call mathutils, and you just call that particular method while passing in your parameters. Okay, so this is basically a static method. Now, a practical scenario where you would do something like this, if you are writing what we call a facade, right? Let's say you're trying to have a way, a static or a good way, a well-designed way of making API requests. For example, you're calling some, servers, or you're calling some websites, right? So you can actually have a class used for that. So I have a request, for example, and I can then map things like my get request, okay? Things like my post request. Now, you don't want to do this. There are libraries that can actually do this, right? My delete request, okay? So you can say request.delete, right? What do you want to really pass in? You want to probably, pass in like the URL, okay? And maybe whatever it is, I don't know, some IDs, all right? You want to pass in, I don't know, maybe you want to pass in the URL, call that the URI, but let's just say the URL. We also pass in data that we are posting if you're posting data, right? Yeah, so you can pass in, you can basically define, a class that is well structured this way. So you can say request.post, right? You can put in the values, you can say request.get. So you're basically building a facade because you then have the implementation details within that facade in here. So yeah, that was a very simple example. Um, of course, I actually planned that this class would take us longer because I wanted to explain, the concept of OOP in a more detailed fashion. So you have to bear with me. We'll probably round up by 9:30. Okay, you have to bear with me on this one. Yeah, I mean, we have some other details here within this file. I created a different file here that says more on JavaScript. Okay, if you click on that, more on JavaScript, let's preview that. So when I preview this, you see we have some additional details. So we'll talk about class expressions. We'll cover this tomorrow, right? We'll talk about getters and setters. Okay, so we have getters and setters. We'll talk about computed properties. Okay, we actually give some additional examples to inheritance. Yeah, we'll talk about these details tomorrow. But for now, let's go ahead and look at a practical example. Okay, a practical example of applying classes and working with classes. So let's just create a new file. Let's call this practical example. Okay, let's put that together. Say.js. All right. Okay, so in this practical example, we're going to build a very simple employee record system. Okay, by the way, it can be anything. I mentioned the other time prototyping. Maybe you might have heard me before in this class or in a different session when I mentioned prototyping. Now I look at building applications. Developers need to really learn how to prototype with code. Okay, so you are talking to a customer, a client, or your friend, and you are discussing. I want to build a system. I want to build a system where I should be able to, create. Let's delete this file. Let's make this more. I'm going to make that a folder instead. Okay. So let's make that a folder instead. I'm going to right click here, new folder, practice. All right. And within the practice, I can create the files I want to create. Okay. So let's start by creating products.js. Now within product.js, we are discussing with a friend or a client and we want to build, a class that we can use to model product behavior, right? We want to be able to create a product, delete a product, update a product, and stuff like that. So this is going to be simple, right? It's going to be very simple. We have a class. We call that class a product, right? And within that class, of course, when you create a product, you should have some details about that product. So what I'm going to do right here is that I'm going to have a constructor with some product information. It can be product ID. This can be generated on the fly, by the way. So we can have like product name. We can have like product maybe price, right? Yeah, let's just work with these two for now. So we can simply say this dot name equals name, right? We can say this dot price equals price. Okay, that is price with the equal sign. All right, so we can actually have maybe an ID, right? Because we want to be able to create an ID. Now you don't necessarily need to put that here. You can just go ahead and say this dot product ID, right? Product ID, and then you have a way for generating some unique IDs, probably with some libraries or using date time functions. But if you don't have one, then yes, you can of course go ahead and include one, product ID. So we just map that to product ID. So when someone says, I want to create a new product like apple drink, for example, you say equals new product, right? And then you put in the ID, let's just put in some numbers there. And by the way, this can be an int, okay? And we can also put in the name, an apple drink as a product, and then the price can be like 1,000 naira. Okay, so if you decide to check out, okay, what exactly does this look like for now? Of course, you can print that. If I go to practice and I say node products, right? So now we have an error. Let's see where our error is coming from. It's saying print not defined because I keep making these mistakes. This should be console.log. Apologies for that. So let's run that again. So now we have the product information. What are some things you should be able to do, after creating a product? You probably want to probably save the product to DB, save products to DB, right? Or you can just say create, okay? You can just say create. Now, when you say create, what you want to do here is you want to save the record to the database, okay? Let's just construct an object. I'm going to call this product object, right? Okay, so let's construct the product object, and the product object is going to contain the same set of details, right? Product ID equals this dot product ID. Okay, so probably this is what we should have instead. Product name. Okay, I keep using equals. This is the product name, so this should be this dot name, right? Remember to put your comma there. Okay, and we also have, that is also a comma, product price, right? Products, come on, price. Okay, we have this dot product price. I think that is just this dot price. All right, so what I'm going to do is I'm simply going to return product object. Okay, and I'm going to return this probably with an additional message. Yes, you can return this with an additional message. So maybe you want to include something here. Let's just say product object dot message, which of course you can just append into this object, right? If you want to do that, you can say the product was created successfully, right? Okay, so so if I should call dot create, right, as a method, let's run this. Let's see what we get. So now we get the object with the product ID, the product name, the product price, as well as the message. Now, ideally, you want to point where you can simply call a database and you save your record in there. If you're using MongoDB, Postgres, whatever it is, we'll get to that in the future. But we're just showing you an action that you can perform on the product. We can have delete, where you probably want to pass in the ID, right? But I mean, in this case, you probably don't need to, because you already have the product, created here, which means you have the ID. So you can simply, I mean, this is not very practical. You won't create a product and delete the products, right? Straight up. So in this case, you probably want to have some sort of, static method that you can call. And if you have a static method, you can actually call that static method, even if you don't, really define this product with a constructor, right? So you can simply say you want to be able to call this while passing in the ID, and then you simply, run a query to delete the record from the database, okay, given the specific ID passed into the method, right? Into the static method, correct? So which means you can actually come in here and you can just call product dot delete, right? And you put in the ID just like this. If you already implemented your database code, it is simply going to perform that delete operation, and it will return product was deleted successfully. Okay. All right, so this is just an example. It's a very simple example. I'm going to try one more example. We still have some time. This time around, we would try out some additional controls here. So this is an employee record system. And in the employee record system, by the way, let me spend the next 1 minute looking at the charts. Okay, so apart from getters and setters, I said we're going to cover this tomorrow. Can the class name products? Okay, I think I probably, I don't know. Okay, so please, on the class of product, can you identify the properties, behavior, and values? All right, let's go back to that again. Okay, so on the class of products, these are the properties we're looking at: ID, product ID, name, and price. Okay, and the values then becomes this product ID, the name, and the price. All right, then the behavior, the methods, creates. All right, so now we are mocking. We're just trying to create something that will be used in a business environment, right? So just like we had human.work, human.this, human.that. Okay. Um, Someone said my screen is static. Okay, so is it the same for everybody? Please let me know if my screen is static so I can stop sharing and share again. Is it the same for everybody? Can you guys see my screen? Is it static? Because I'm actually moving, from one file. It has okay, so it has freeze. Okay, okay. All right. Hold on, please. Okay. Let's do that again. All right. So what about now? Is my screen still static? Can you see my screen very well? Anybody? I am sharing again. Thank you, Binta, for that. Okay, good. All right. So I'll take that again. In the product class, these are the properties, product ID, name, and price. Okay. And we have the values. These are the values right here. The value, this is the ID, this is the name, and this is the price. All right. So which means we can simply, go ahead to say the product dot the ID, the product ID will get the value, right? The product dot the name or the product dot the price, and we'll get the value. Okay. So when we say apple drink dot create, this is the method or the behavior that we've attached to this class, which is create. All right. And this is what we basically perform. This is the action we perform. So I hope that answers your question. Um, okay, someone just said it has frozen again. I think it's probably my network. Please confirm that. So that was from Butch Tech. I hope I answered your question. Okay. Edwin said it's okay now. All right, good. So let's jump into the employee.js file. Let's quickly, see what we can do in here. We're going to create an employee class. Within the employee class, we should be able to have methods or behaviors like get details or, work. We should be able to create, we're also going to create an admin employee that would inherit from employee. And the admin employee should have additional methods that a regular employee should not be able to do. Okay, so let's go ahead and create a class employee. All right, and I'm going to create a constructor right here. Would have the name, would have the employee ID, would also have the position, right, of that particular employee, more like the role. Okay, so this dot name.
Hi, Mark.
Yeah, hello,
Hi,
Amaka. Who
Mark.
is that? Can you?
Can you hear me?
Yes, I can hear you.
Okay, it's Amaka. Your screen is frozen again.
All right, just give me a minute. I'm going to switch my network. Please give me a minute. All right, let me go ahead and share my screen again. Apologies for that. Let's see. I think that it should be better this time. All right, to confirm, guys, if you can see my screen. Thanks for that heads up, Amaka. If you can see my screen, please let me know. Okay, so if that happens again, please feel free to interrupt me, Amaka. Thank you. So we have the class employee, we have the constructor with the value with the properties of name, employee ID, and the position. So we're simply going to repeat, that boilerplate code we keep writing equals name, this dot employee ID equals employee ID, right? And this dot position equals position. Okay, so those are the values we have for the employee. All right. Um, okay, and we are going to add the behavior. So let's say get details. All right, and we'll simply return the value of saying, okay, this is the name of the employee. So this is the name. Remember, is string literal, so we need to pass in that sign in order to have the value show up. So ID, all right, and we also need to do the same thing here. We'll simply say this dot employee ID, okay, and the position, all right, we'll simply do the same thing as well. This is the position. All right, so let's also add the work method that I mentioned earlier. This is simply going to do console.log with yeah, so with a string literal here that says this.name, this.name is performing regular work or regular task. Okay, so this is a regular employee. Now we're going to have a class of admin employee, and we're going to extend the employee, right? So we're inheriting from employee. Okay, so let's also include a constructor, and we'll pass in the name, the employee ID, the position, but this time around we're also going to include department. Okay, department. All right, so when we say super and we say name, employee ID, and position, we are simply saying, take these, attributions, right, from the parent class, which is everything you have here. Okay, so we have passed that with the super. Okay, and now we can include the department, which is the new thing here, equals department. All right. Okay, so that is basically how you work with inheritance. We are going to override this get details. We already have get details before. We're going to override this, and this is basically, as I mentioned earlier, polymorphism. Okay, all right. So let's go ahead and uh, show that we're overriding the get details method to include the department. Okay, so now we're overriding it to include the department. So what we would simply do is to call the get details value, right, in the super or in the parent class by simply saying return. Let's go ahead and put this here. Okay, we'll simply say super.get details, so we can get the values right from the super class, but we'll then include something here, which is the departments. Okay, and right here we can put in this dot department, which is the new value that we have added. Okay, and we can also add even more actions that the parent, the regular employee would not have. Something like manage employees, right? We can simply log. We can say this dot name, which is the admin. So this is referencing the admin, of course, is managing other employees. Knowing very well that a regular employee should not be able to call this action, only the admin employee will be able to call this action. All right. Okay. So we can also say maybe assess um, sensitive information, because this is a method we're creating here as well. Only the admin should be able to do this, right? And I can say console.log um, this.name, which is the admin, can access sensitive information, right? The regular employee should not be able to do that. Okay, so let's go ahead and create. Uh, let me show you what this looks like. By the way, so I just had to reduce this. So you see, we have the employee, right? We have the admin employee where we perform inheritance. Okay, so let's go ahead and increase this back once more. All right, so let's continue. What we're going to do right now is to create the instance. Okay, so let's say let's regular employee. Let's just say we are creating instances. Okay, so we'll call this a regular employee and we say new employee, right? So let's pass in the details. Let's say John Doe. Let's put in the ID, something random. Okay, so this guy is probably a software developer. All right, and now let's create admin employee. Admin employee equals new admin employee. Okay, so let's call the admin employee John James. Okay, so John James has an ID. Okay, that's the string ID, and this is an IT manager. That is the role, which is the position, and then now we have a department. We can call that the IT department. Okay. All right. So let's display some details here. So let's just say display details. So we are simply going to say console.log, and we're going to bring in the regular employee dot get details. Okay. So let's print that node employee.js. Now this is the regular employee information that you can see right here. If you look at this very well, it has position, it does not have department. So if we say console.log admin employee dot get details, remember we did some override there. Okay, so if I run this now, you see this actually gives us what do we have? Okay, so this is not very good, right? It's not very good because what we are getting from here is that we actually returned this actually returned the entirety of get details, and the reason for that is because we made a mistake here. We called the super.get detail, but we did not call the function properly, right? So that's why you see we have that error. So let's call it properly now. You see we have the admin employee name, right? The ID, the position, as well as the department, while the regular employee did not have a department. Okay, and we can as well go ahead and check out some of the things that the admin employee can do that the regular employee cannot do. If I call regular employee dot and I put the dot notation there, you see we don't have some of those functions, like access sensitive information. We don't have manage employees, right? That is not here. So even if I say manage employees, right? If I say manage employees and I should run this, let us see. We have an error because that is not part of what the regular employee should be able to do. But if I say admin employee not manage employees and I run that, you see it tells us John James, who is the admin, is managing other employees. Now we have experimented with polymorphism, right? We've experimented with inheritance here. Okay, so go ahead and play around with this. I'll see you in the next class and we'll discuss more details around, working with objects. By the way, this is going to be added to the repository. So git add, and I'll say git commit, added the class materials for OOP and okay, with example code files. Okay, so let's go ahead and push this. So please do well to clone this repository and experiment with this. So I would simply share this with you, and of course do well to follow me on GitHub, right? You can as well follow me on Twitter. Thanks for joining in. I'll see you in the next class. Good night. Okay, yeah, so you can ask your questions tomorrow if I did not take everything here. So have a wonderful evening. Bye.